So this is just the agenda for today. So I'm really hoping to keep this kind of as an open discussion. So if you have any questions, or if you have any maybe comments or feedback, similar scenarios that you've encountered, please please come up and have a discussion with me. I would be really happy to kind of see your feedback. So I'll give a brief project description first. Talk about the contractual BIM for this job. It was actually the first job where we've encountered contractual BIM, so it was quite a unique learning experience for us. And then a little bit of discussion about the laser scanning that we did for the existing building. Some talk about the collaboration that was involved, as well as the specific challenges of the power plant design, which was very, I guess, there was quite a few. And it was a very unique project, whereas we had a lot of different systems, and there's a lot of learning involved in it. So for this project, it was over $12 million of mechanical scope, so it was a fairly large project. There was 4,600 square feet of new build of the power plant, and also we were replacing some of the existing spaces. So this was for the Lionsgate Hospital complex. So this power plant was actually the main power source for all of the different buildings within the Lionsgate Hospital. So some of the systems we worked with, there were steam systems, hydronic systems, domestic, and medical gas as well. So some of the, I guess, unique features that we had to do was there was the scope of designing the pipe supports, as well as the boiler platform for maintenance of all the associated equipment that went with the boilers. Another piece of really specific equipment was the deaerator for the steam system, as well as the condensate receivers, flash tanks, and multiple heat exchangers and pumps. So one of the big parts of this was actually the retrofitting of the existing building. What we had to do was, there was an existing tunnel where we had much of the distribution piping was running. So there was quite some stringent, I guess, clearance requirements required, because this was their main tunnel to get from building to building. So this is where all of their supplies need to go through. So we need to make sure that we kept the clearance requirements that they required for that access that's required in that plant. So there's 2 new water-to-water energy transfer stations, which transfer the heat from the plant to the different buildings, as well as a new water entry room that was all to be in existing spaces. So this was like break rooms or offices that were retrofitted to make space for these new mechanical rooms. So is there any comments or anything, any questions about the job specifics? Pretty quiet room here. Okay, I'll go into contractual BIM. So I guess everybody in this room knows what BIM is, hopefully. How many of you know what contractual BIM is? Show of hands. Have you dealt with it? I guess, has anyone had any specific challenges with contractual BIM yet, before I get into this? I see some smiles in the room. Yeah, so there definitely is some. So I'll talk about a little bit about what it is. So contractual BIM, basically in the tender phase, there's some stipulated requirements. So the owner might say, I want it for facilities management, or I want it to improve the schedule. So what typically happens is they have a project execution plan, they have some requirements, maybe some workflow. So, whose role is it to be updating the model? Whose role is it to include changes in the model that is maybe brought on by the owner or the consultant? What that level of detail of the model needs to be. So a lot of times what we'll see in contractual BIM is usually there's quite a high level of detail that they're asking for. What we've also seen is a model accuracy table, so indicating what the accuracy needs to be on site versus what's in the model. So if you're out by a couple inches, not a big deal. If you're out by a few feet, okay, we might need to go back and update the model. And then, yeah, so like I said, asset management. So for this job, there was the requirement for asset management. We were still actually working through it, so it is quite a cumbersome topic there. But yeah, it was definitely a learning experience to see what the different aspects that were required for this job. I guess one thing to note was originally in this job, there was the requirement to track geometry changes between the trade model versus the design model. And throughout the job, that requirement changed. It actually became too much work to be tracking every minor change that was happening because the design model wasn't quite to the level of detail that it needed to be in order to facilitate that. I'll be going into this in a little more detail further on, but that's one of the most, I think, noteworthy points of the contractual BIM that we noticed. So some of the benefits. So definitely a better defined scope, better collaboration, so everyone's kind of forced to work together. And it does facilitate easier implementation for fabrication. So because there is that requirement, we're already doing that work. So now we just take it a little step farther and we're able to prefabricate and I guess find those benefits for ourselves as well. So drawbacks and challenges, it is fairly new. We've only seen maybe a handful of contractual BIM jobs so far to date. And so with that, there's some, I guess, there needs to be some clarity in terms of what the scope is. Not everybody has a full understanding of, I guess, what BIM is, especially with the owner. Sometimes they know what they want, but they don't quite know how to get there. They don't really know the specific questions to be asking or, you know, what it is they actually require versus what they want. So definitely there was quite a bit of time clarifying that scope and then also clarifying roles and responsibilities. So what was it that we needed to do versus what it was that the consultants needed to do, what information is required from the owners. At the beginning of the job, it wasn't that clear. And then lessons learned, I think the big one is all parties need to be educated. So everybody needs to understand what BIM is, what it can do, and what it can't do. That's the only way that we can properly define the scope. That's the only way that we can get those true benefits. Go ahead.
Hi, this is Anna Kuchan from Lisbon. I just had a question about if people were actually meeting the contractual BIM as such. So were people meeting the LOD at the right times and things like that?
I would say meeting them, yes, but I guess because it wasn't quite defined clearly at the beginning, it wasn't quite clear what the requirement was, so you could say yes and no. Like, we were definitely trying to do our best. And I think we've exceeded, at the end of the day, what the requirements were. But at the beginning, probably there was a bit of ambiguity in terms of, is this what we're supposed to be doing, or is this not what we're supposed to be doing? But I think in the end of the day, yeah, we eventually got on track and started to get to the point where we knew what it was we were trying to do and meeting those goals.
Marcel's Bell's gone, so I'm kind of building on that question. And to your last bullet point with lessons learned, what was your most notable successes, your most notable failures, and lessons learned from that failure? All parties needing to be educated about the framework of requirements.
So lessons So, sorry, repeat that one again?
Most notable successes, and then some of your most notable challenges and the lessons learned from those challenges.
So definitely the most, I think, notable challenge was defining roles and responsibilities. There was quite a lot of back and forth with the consultant to determine what was our scope and what was their scope. So every time there was an SI, do they need to update their model, or is it up to us to be updating ours and then reflecting it back? The most notable success, I think, absolutely was the collaboration. So we had quite a few, actually weekly coordination meetings with the owners, with the consultants, and everyone was providing feedback quickly, collaboratively, and I think that was one of the big things that I noticed about this job.
And was that before IFC or after IFC?
That was after IFC.
Thanks.
You're welcome. Impacts on the workflow. So for us, I guess there was quite a few impacts because this was the first contractual BIM job we encountered. Our estimating team didn't quite know what questions to be asking. Our project management team didn't have a good idea of what that asset management meant to them. The field didn't quite understand what our obligations were in terms of tracking changes. So for us, what I wanted to say was going forward, the estimators need to have a better understanding of the BIM scope. So recently what's happened is every time we've had a contractual BIM job, the estimators will actually come to me, ask me to review the documents, and then ask me for feedback for questions that they can present. And I think that's a very good way about doing it. For project management, so definitely, after this job, I think we have a better understanding of what asset management means. How to, I guess, in terms of project management hours, allocating some time to that. And then the changes within the equipment submittals. So asking for certified dimensions, making sure we have the installation manuals before receiving the equipment. Those were some of the big things that we did normally before, but for this job, even for the smaller pieces, we made that effort, the extra effort to find that information earlier on and try to incorporate it into the model. So increased coordination and communication. So not only by us in terms of the BIM team, but for the project management team, it brought up a lot more issues that they needed to deal with. And I think that's something that was overlooked in terms of the additional hours that were required. As for the field, our foreman was actually amazing for this job. It was actually his first BIM job, so he was a little bit shocked in the beginning, but he quickly saw how all the benefits that we could provide to him through BIM, and he was completely on board within a couple of weeks. He's a great foreman and he knows his stuff, and he was coming in weekly to talk to us, provide his feedback on our model, and give us an overall better design.
We actually view the 3D model, and every week we set a time that we can come to the office and sit together, and he talked to me directly about the concern he had, and the result, that's very efficient.
So same thing with an external, the collaboration. I don't know if everyone had realized that we were going to have weekly meetings with the owners and the consultants, but that's something that eventually had to happen. So one note I wanted to make was for the asset management. I see a lot of times with these contractual jobs where they're asking for it is they'll say they want it, but then they won't say exactly what it is. So what pieces of equipment require this asset tag, how much information for each piece of equipment is required. That information, it could build up very quickly. And I don't know if there's any owners in this room, but it would be really nice to have an idea of what it is earlier on in the job, so we could.
I just
Sorry.
wanted to comment on that. Is because of this project, first of all, it didn't start through the design. It started mostly almost at the end. But there was that information available in which I don't know if you've got a document called VGS or VCS.
Yeah.
In there is a list of all the track assets for the owner, and all the different parameters that they need to be collected during the construction time. So that information is available.
Yeah.
Or
So.
was available.
Yeah. So that for this job, it was available. We did spend quite a bit of time trying to clarify with the owner what was, I guess, like I believe when I was looking at it, there was just like, list all the valves. Well, do you need all the valves, or are there specific valves you need? Or, there's like the little details that kind of need to be talked about. So maybe the better way to say this is, if it is available, maybe we need to sit down and have a better understanding of it.
Maybe,
Yeah.
Yeah. It's I think a lot of it is having a team kickoff meeting
Yeah.
before construction, because that you can talk about what the issues are,
Mhm.
and there could be a lot of clarification, and then have, as you keep on saying, that like the understanding of that being scope.
Yeah.
Like the owner can have, like this is what we want,
Mhm.
as you keep
Yeah.
saying. But there are some times, depending on a project,
Yes.
that has to be adjusted to it.
Absolutely.
And that is a good opportunity to start clarifying all this stuff.
Yeah.
It could be like a mandatory walkthrough, but for the model. instead of-
Similar to that,
Yeah.
exactly.
Yeah.
Yeah.
I think the challenge for this project is the design model we have is not construction level. So basically, design level is good for drawings, 2D drawings, which is fine. And when we started the project, we think the design model is good enough. We can just copy to our model to bring up. But actually, there are a lot of things are missing in the design model. Long, small pipes, but with insulation to help to take care of the space. So it end up we kind of have to 80% redesign the power plant. So by saying that, you talk about this for the equipment online drop-down cut sheets, and they use their parameters in their design model, like mark, some labels
Oh, yeah,
from
the
design
labels.
model,
Yes.
from design model. And our model, because we have to regenerate the model, we use different parameters. So different labels.
Yes, and that's actually, that's a good point, because in reality, the parameters or the naming convention or tag
Yeah.
should be similar, because that way you can actually do a comparison between the two.
Exactly.
But if you don't have that, then it's almost impossible to
Yeah.
That's actually a very good point. The naming convention and tagging, that's actually a pretty big one too, because a lot of times that naming convention gets clarified throughout the project, and maybe it might change slightly, and then your models, you're going to have to update those as well. So that's another part of asset management and trying to align everything.
Defined right as early as possible.
Yes, absolutely. I think that's
Unfortunately, things develop as you go along.
Yeah.
And you have to retrofit
exactly, yeah.
detail.
Yeah, but it's about the consistency, right?
Yeah.
Because one of the things that we find is that the designers may use for one particular equipment, they may use a mark to give you the
Mhm.
tag.
Yeah.
And then in another one, they use level 1. And
Yeah.
another one is a tag. And it's like, how do you find all that
Yeah,
information?
Yeah.
You have to
An
make sense of
execution
it.
plan.
Exactly.
Especially there's something missing. Like in design on some valves are missing, and we need to add valves. We need to figure out how the tag works.
Yeah.
Specifically valves, like they're using the automatic numbering.
Mhm.
Yes.
Yeah.
And like you said, some of them are only shown on the specs, they're not even modeling.
Yeah.
And I hear, part of the issue was that the design team sort of took the approach that we've never done this pipe installation, some of these things.
It's not even there.
Yeah.
Even though it was required from the beginning. So
Yeah, I think
Just because it's a
yeah,
first project.
yeah. I think it's the learning curve of the first project of contractual BIM. I mean, like now the jobs that we're seeing are significantly better. They're starting to catch up, and I think people are starting to understand what this means. And it's go ahead.
To define asset management, you mentioned that a lot of asset management documents and asset management. Is that asset information management, or
Yes.
define when you refer to that?
Yeah, so what I meant by asset management was for facilities management, it's basically whatever the owner's requiring us to track. So providing information like how often the piece of equipment needs to be maintained, when the filters need to be changed. The owner needs a lot of that information, and they're looking to BIM for, I guess, a shell to store it. And that's kind of like, with us, we don't see very much of, I guess, effects on our workflow for that. Usually what we're asked to do is provide the model. It's up to the consultants to be making sure all the tags are correct and things like that. And then all we're asked to do is upload the information to a database. Sorry, go ahead.
Yeah, so if I can reflect on this from my experience with YVR, because they're doing the same thing with digitizing this whole operation and maintenance asset registry system, is I think, as you had said earlier, there needs to be an initial kickoff meeting where this is established. But yes, the biggest challenge is the consistency of tagging, or one singular identifier for multiple scopes of devices and equipment, and that is one of the biggest roadblocks I see to having, I guess, a common understanding. And second to that is essentially needing to have a framework of successive reviews of this list, not only by the
I
owners
agree.
And the designers and the contractors, but by the facilities maintenance department, most importantly. Because at the end of the day, if we develop this system that they have no understanding or experience
Absolutely.
prior to, then it's just a big disaster waiting to happen. That's just from previous projects where I've experienced this.
And I think this job was a good example of that, where we actually did get a lot of feedback. So there was a lot of back and forth with operations and a lot of back and forth with the owner. So it did get to that point, but it took a bit of effort. And I think this job is definitely a very good example of that happening.
Lessons learned.
So this is kind of just a little funny example I have here. So even though we requested certified dimensions, asked for installation information, surprise, surprise, what appeared on site was actually some extra control panels for our boilers. So what happened here was even our supplier didn't know about this. It was the manufacturers. It wasn't shown on any documentation that these were coming. So what actually ended up happening is we had a meeting with our supplier, with the manufacturers of the boilers, and through the model, we actually found the best location for these control panels. So this is a very, very tight room. We didn't want to block the boiler access. We didn't want to block the burners. There's different requirements in different areas. And because we had a model available, they could actually go before installation and tell us, okay, this is the best spot to put it. And this is coming from multiple different sources, right? Not just through emails or whatever. We had an actual meeting and found the best place. And I think the model made a big difference in this scenario. So I'm going to start going into laser scanning here. How many of you had experience doing a laser scanning or with point clouds? Okay, so a fair number of people. So I probably don't need to explain too much. For those of you who haven't had experience, basically laser scanning, you take a robotic station out to site. It shoots a bunch of points in different directions, and it makes a 3D image out of those points. There's the option to include color, where it would actually take a picture and overlay the color information over this point information. So this is just an example of one of the part of the corridor that we were working on. So this was utilized in the main corridor, the main tunnel, as well as some of the existing rooms where we were replacing where we were putting in the energy transfer stations and the new water entry room. So I guess let's talk about the benefits first. So coordination and collaboration. The fact that we had scanned the tunnel, we were able to prefabricate many of the supports that are required. So I don't know how many of you have dealt with steam systems, but there's quite a lot of requirements in terms of how they're supported. So as you can see here, we have these racks that were set up to support the pipe along the tunnel. So within the tunnel, as many of you know, floors are usually not very level. There was a deviation of, I think, about 2 inches from one side to the other. So 2 inches of grout is a bit much to be including. So we actually had several different configurations of racks to, I guess, accommodate that elevation difference within the tunnel there. So here we have some more benefits. So we could quickly identify issues. So very quickly in one part of the tunnel, we realized that the pipes were not going to fit in the ceiling space. As you can see here in the design model, they actually have it running at about this level. And I guess they had noticed also that it wasn't going to be able to run as high as we had hoped. Another example is running through some doors. There was plans to relocate this door in the design model, but what we noticed after we had modeled in our piping was the door was too wide. It wasn't going to give us enough spacing to get through that wall. So we actually worked with the general contractor to resize the door slightly to allow for that. The other, I guess, real benefit to scanning that tunnel was there was a bit of an angle within the tunnel, and that angle was not a true angle. It wasn't 30 degrees, it wasn't 45, it was, I think, 35 and a half or something. 33.5? So, in the specs, we were only allowed to use manufactured fittings. So what this meant was our steam pipe, which is welded, now we have, how are we going to make that work? Because we had realized this early on, we actually saved quite a bit of time. We still need to request that we could have a custom fitting for the spot. But because we had realized so early on, that RFI had time to make it through the system. And I think there was a great benefit to that. Otherwise, we would have been installing this and then found the problem. Maybe this would be a good time to ask the audience, have you ever seen any major benefits that you've seen from doing laser scanning? Quite a few of you have used it before. Anything you guys want to share? Yeah?
We're doing a hospital project right now with the existing boiler and kind of gutting 80% of the stuff, but 20% has to stay in. So we're basically seeing where our design is conflicting with the existing pipe. Really helpful.
Yeah, so for this tunnel, there was some existing systems in there. And one thing that we had to do was make sure we could actually demolish that after we've installed our new piping. And because of the spatial constraints, having that scan and knowing exactly where that pipe is made a big difference as well.
What's exactly involved for you guys to take it from the point cloud to drawing?
So we don't model over the point cloud or anything like that. We use the point cloud as is. So we take the model, the point cloud, insert it into a Revit, and from there we model around the point cloud. We don't do any additional, I guess.
I think basically we import point cloud into Revit and overlay. First we overlay with the architecture drawing, and we can see there's some deviations. And so also with mechanical model, you can see some pipe just doesn't run as the model, so we have to modify that. So doing laser scan actually gave us much better idea that what actual lens actually makes outside. I think the challenge when we do the laser scanning for this project is because hospital, and we can't do it on daytime because it's running. We can't take this whole content block, so we have to do it in daytime.
Yeah, Harry was a real team player. He went in the middle of the night to scan these rooms.
Another thing they are helpful for this one because they have very long tunnel, and we have to be multiple scans. Sometimes it's hard to, especially with the rear angle, sometimes it's hard to register them properly. So what we come up with plan, we put some additional markers on the wall, so that for multiple scans they have more points right to one thing. Another thing is we leave this mark on site. Not the actual mark, we put a drill a small hole on the wall. We use that to provide dimension for actual piping for installation.
Yeah, so we actually use those same points as references during installation, and that way we can increase our accuracy as well.
Exactly.
Did you find any technical issues with handling all the point cloud data within Revit?
So I guess the thing is you have to have a real understanding of what the resolution you require is, right? I mean, obviously it's nice to have a very high resolution, but then it's going to start slowing down your model. So to find that nice balance is kind of where you want to be. We've done it enough times that we have an idea of, I guess, the resolution that we want, so that it's enough information, but not slowing it down.
I did upgrade my computer. But the thing is, when you arrive at research, because you work on certain views, so in certain views you can hide certain points because there are multiple files.
Yeah.
You can hide other ones.
Yeah. As well as you can section them in Revit and
Yeah. There's some techniques.
So one of the things I want to bring up with laser scanning is we are the contractor, so this was done very late in the game. I mean, if there's any owners in the room, I think it would benefit the owner to do this scanning and be able to provide that to the consultants or have the consultants do it. And so when they're doing their design model, it is to something accurate. Because from this job, they did the design from as-built drawings, which I can show you in the next slide. This is the deviations we found. So at one point, we're almost 3 feet out. So that's quite a big deviation. So if we had just followed the architectural as-builts, all of our prefabrication would have had to be redone. So every time, sorry, go ahead.
Yeah, I would agree with that, what you're proposing, because the order of sequence in which our laser scans are used was exactly done the same way that Division 15 is in that the laser scans were used as the governing guideline or governing information of how to model in that room, because the design models were actually pretty far out in terms of location and in terms of existing conditions. So having that scan done prior to be a back check or an initial guideline for the design would probably eliminate a whole lot of back end work.
Exactly, yeah. Anyone else? Okay. So some of the challenge we had is linking and registering scans. Because the tunnel was so long, like Harry had said, it was very challenging. Like if you have a square room, it's different. But this is just, like the tunnel I think was 8 feet, is that right? 8 feet wide?
Yeah.
And very, very long. So what we ended up having to do was we actually split it into different sections. So as you can see here, we've numbered the different areas. And then from there, we sectioned them off. So we modeled up to a certain point, included the new scan, modeled that. And that way, I guess, like you were saying, it allowed us to have a faster model, as well as it allowed us to, I guess, make minor adjustments as well as we go. So another thing is our scan, we did it before demolition of and construction of new walls. So in hindsight, I think it would have been a good idea to go back and scan again after the construction of the new walls. So for example, things like that door that I said was relocating. It would have been nice to know exactly what that door is afterwards. Go ahead.
How long would it take? Did it take you guys to do the scan?
So normally it's about 15 minutes per scan. And so that project I think I spent 3 nights. So each night 4 hours. That's one for 1 each. That totally about 6 people.
What kind of scanner were you using?
We run the scanner.
Yeah, we rented the Faro Focus. We could talk about this later, but there's quite a few new technologies out these days that would have made the registration a bit easier for us. Like, when did we do this? Over a year ago?
Almost.
Yeah. So, I mean, I think the reason we went with the Faro is because we were familiar with it, and it was something that we had used multiple times before, and we wouldn't need retraining and things like that. But now that there's so many new technologies, we potentially could be looking to something new. So like Harry said, to minimize disruption, we had to scan at night. So it wasn't just the fact that I think it's because it was a hospital, they had concerns about, using a laser there, as well as because it is, like I said, a corridor that's used very frequently to transport different objects from different buildings. They didn't want that to happen at the same time. So it had to happen at night. And then the other thing that I had mentioned about going back and rescanning, we actually, like I said, that one corridor where we couldn't run in the ceiling space, we didn't really realize that until we had brought the scan back. And we actually ended up having to rescan this whole area, which they're calling the carpentry, in order for us to reroute our pipe into that area. So another challenge that I find with laser scanning is it's great for determining where objects are, like geometry, not so great for distinguishing between objects. So what I have showed here is the difference between a permanent object and a temporary object. So, for example, for a temporary object, things that they've just stored there, drums, shelving, whatever. One thing that we didn't realize was a permanent object was this yellow thing right here. What that is, it's a door stopper. And because it was kind of the shape of a shelf, we thought that it was something that was temporary. So actually we ended up running pipe through one of these, and luckily through a site review we had noticed that that was actually a permanent object, and we had gone back to fix it. The other thing is examples like junction boxes. As you can see here, that's a photo, and that's the scan. It's very hard to tell that that was a junction box there. other things like light switches, or another example we had is a door actuator. So not all of the doors had actuators, one of them did. So once again, through a site walkthrough, we noticed this and had to reroute some piping. So that's one of the big, I guess, lessons learned, is even though you have a great scan, it's always good to go out to site, have that walkthrough, review it, make sure you have a good understanding of what's there. So does anyone want to, I guess, share any similar experiences where they've had challenges with distinguishing objects within a point cloud? No? So I'll start going into collaboration then. So at the time, we didn't really have, I guess, an online platform that we were happy with. There were several different options, but they didn't quite, I guess, provide us with what we specifically needed in terms of review and collaboration. So what we did was Harry made his own. He, do you want to speak a little to it?
Yeah, so we started to build our own website initially for VR, AR, and MR application try. But when we started this project, we realized there's some, because the key for the success of BIM project is share viewed model, right? Not just by BIM, but by everyone. So we think we already have this platform, by use our platform to design something. I think we have a small video here.
Yeah, you just have to go to the next slide, I think.
So let's.
Yeah, there you go. So I think this is a big one here, being able to section a point cloud just through your web browser.
So you don't need any special software for this?
Yeah, I think it was just Chrome.
Yeah, as long as you have the internet and popular web browser, you can just build model.
So is this something you have tried on a larger scale? Because this project, I guess, is a little on the smaller side.
What do you mean, like, it works on PC as well?
No, like a big hospital or a big...
Yeah, there is a concern for complicated model. The internet speed is a concern. And so we end up, for this project, we have to divide, let's say we have a power plant, we have very complicated pipes in that room. We have to create a separate models that's based on the services. So let's say we have steam system, hydronic system, and vent system for different models. Hopefully, with 5G coming, it might be better. So I can quickly show the website. So anyone with cell phone with data map.
Oh, I'm not sure. Oh, there it is. Yeah.
So anyone with smart device, iPhone, iPad, Android phone, you can just open website. It's LGHPP, beamfolder.com. So here you can see all the model we have for this power plant. So you can see we divided all the piping layout based on the systems.
So I think the thing I liked best about Harry's website was the ability to the model tree, I guess, is the biggest thing I found. So being able to look at specific systems, being able to turn the installation on and off. With a lot of the model viewers to date, they don't really allow for that to be turning different systems on and off. So it makes it way easier to be reviewing a model. So say, I only want to be looking at the steam. I don't care about everything else right now. I just want to make sure the steam is modeled correctly. We have the drip legs where they need to be. Then I can turn everything off and quickly review it. And actually, our QA/QC manager was using this web link a lot just to do his work as well.
So you can see you can cut sections with point clouds and or piping, and you can do dimensions. So that's so the first thing, there's no installation required. Anyone with a smart device can see the model. So that's very helpful, especially for site people. So they come to site, they bring their cell phone to see the model, compare with the site condition. They know where the pipe to run, and they can do dimensions on it. And another thing is another feature we like is the PDF linkage. Basically, it's soft drive linkage. Let's say you have equipment, and there is a link. You can click. It will open the shop run. So people, because we have the shop run keep updating, we always keep the most current ones on the left link. So especially for everyone, we can see what exactly the equipment dimension, check all the specs. And another thing we found very helpful is we have subcontract to build the platform for the boilers. And for them, because the platform, we have so many pipes, sometimes conflict with the pipe. And with this one, we can easily share. They send their 3D model, and they integrate import their model into ours and put on the website, so we can see the model together to identify the issues.
And I guess the other thing is with the properties, because Harry built it, he could select which properties he wanted to show, which was a really, I guess, benefit, because as I guess many of you probably see, like with the online viewers to date, either the property you want isn't showing, or it's showing far too many, and you need to go through and try to find the one you're looking for. So it was a much cleaner solution for us for this job.
Yeah, we're glad it finally works.
Did it take you long to build that?
It's step by step, yeah. We didn't full time do that. We just go the wrong way. It does take long. But once you get on the track, it's all right.
So maybe we'll take another little break and ask the audience, are there any online viewers you're using right now that you really like? That's the one that we've, I think we started using it about last year, and it definitely, I agree, it's a very powerful tool.
Because when we started this project, we don't have Retrofitting.
It seems to do a lot of the similar
Yeah.
functionality.
Exactly, and this one, basically this one is just a lightweight viewer, not like a Retrofitting coordination tool and create issues. It's more powerful. But something missing, but I think it's improved right now. Something like cut section of point cloud, I don't think this tool can do that.
It does do that.
It does do that. And also we need to install, we need to figure out how the license works.
Yes.
Yeah, that's. And this one is
You pay what you get for.
just
You get what you pay for.
You can send to anyone.
Well, it's also got the PDF shop drawings also really nice.
Yeah, it's got a PDF link for people equipment issues.
So we use FieldWire as well. I think recently we've just released something else with as a 3D viewer part of that. I haven't fully explored it, but we use FieldWire for 360-degree photos, and then again monitoring all the efficiencies and logging documents and things like that. So
Yeah.
we find that as a good collaborative platform for people on site.
There's a lot of viewers right now available. But our plan for this one, basically this platform is for AR and MR.
Yeah.
Hopefully it works too.
We also use Assemble, which has a web base as well. So again, it's similar to this that you built.
So a little bit more about collaboration here. So like I've said before, we had weekly coordination meetings with the owners and consultants and GC. And I think this job, the success was because of this. I mean, to have all that feedback quickly and I guess collaboratively, yeah, there was a few challenges here and there, but yeah, overall, I think being able to get that feedback was essential to having this job be a success.
Did you find that owners attended regularly?
They did, yeah. At least for the first 6 months, about roughly. Yeah. I mean, once I think the job started to get a little more, move along, we saw less participation just because a lot of the issues were getting resolved. But in the beginning, when there was quite a lot of issues, everyone was very actively participating. So the other thing is the complex questions. There was a lot of very complex questions in this job just because of the systems that were involved. And in a lot of our meetings, we did use BIM. We used BIM as a visual aid to explain these questions. And I think it would have been very difficult to explain them without BIM. Trying to describe what we're doing here. So this is where we had relocated that pipe into the carpentry area, like I had discussed before. There's actually a door on the side here, and basically what we need to do was pipe all this pipe beside the door, bring it up into the ceiling space, and then across the carpentry area. And without showing this, to explain how we're planning on routing this pipe would have been very challenging, but because we could model in, show everybody, this is our intention, do you have any feedback? I think it made that process go a lot quicker. And then with these coordination meetings, a lot of times what ends up happening is it's followed up by an RFI, and then the consultants will issue an SI to follow up with that. And it seemed like a pretty good way to go about it because we could RFI the question, but then it would have taken the consultant a lot longer to understand what it is we're asking. So another benefit that we saw was we had a regulatory organization come and review the model with us prior to installation. So this is TSBC. Basically, the power plant had very, very limited space. So as you can see here, we ended up having to turn a lot of the valve handles just to make enough clearance to walk through that area between the piping and a boiler. This was actually a pretty common occurrence throughout the whole power plant where we had to kind of make minor tweaks to just get enough space to meet requirements. But TSBC was available to provide suggestions to us, clarify what the codes really meant, provide, I guess, knowledge of areas that we need to rework. So some of the things that were commented back was examples like equipment servicing. So with our platforms that we had to design, I'm not sure if I have a photo, but basically you get up top of that platform and there's the sorry, Harry, help me out. What is it that's running above it? Yeah, the economizer is up there, as well as all of the, what's that, ductwork? Yeah, the breaching duct above. So there was very little headroom. Additionally, some of our pipes need to run over top of the platforms. So it wasn't the best access, for sure. But because we had brought them, had them view our concerns, provide suggestions, at the least they knew that we were putting in that effort. to make the best design we possibly could. The fact that we had early engagement, it led to less deficiencies because we had reviewed all these with them, followed their suggestions, tried to make the best we could of the situation. Another thing that this was used for was we had sent them the locations of all our drip legs for our steam system so they could pre-approve this before we start our fabrication. So if we hadn't done this and they said, no, you needed more, or they needed to be in different locations, we would have had to go back and redo all our prefabrication, which also meant redoing all our stress analysis. So having them provide that feedback early on, it was definitely something that I think definitely helped in terms of schedule for this job. The other thing was the replacement strategy for the boilers. They were able to tell us, provide some feedback on how to get these out. I believe there was an opening in the ceiling where eventually these boilers would need to come out. But with the platforms, there wasn't a lot of space to be able to, I guess, navigate that. So here I have an image of an example. So that's a deaerator up there on the mezzanine level and the steam heat exchanger right beside it. As you can see, it's very congested in there. And this is only with the larger size piping. We didn't even include any of the smaller sizes. So that's kind of the example of the space requirements we were working with. Another example we had was our PRV station, so that's right here. And because it is a steam system, we had to look at the stress analysis for this. So actually we looked at several different configurations to try to fit this on that wall. Originally, I think some of the valves were actually over here closer to the deaerator at a pretty inaccessible location. So we ended up trying to, I guess, find the best solution with putting all these valves along that wall. We had a steam engineer or a stress analysis engineer work with us to suggest different options. And this is kind of what we came up with, and I think it looks pretty good. Another example of us needing to rotate valves in order to keep our clearance requirements for access. I guess another challenge we had was some control panels. They were modeled in. Unfortunately, the mounting of them wasn't modeled in. So they required an extra 2-3 inches, which we didn't quite have a space for. So we actually ended up having to move some equipment, change our housekeeping pads. Those are some examples of the challenges we had there. Some other challenges we had. So because it was a steam system, we worked with them in the past, but it was quite a complex steam system in this job. And we definitely had a learning experience in terms of understanding steam trapping, dealing with condensate, different pieces of equipment that went along with steam systems, lots of reading of manuals and installation manuals, and just kind of generally understanding that system, I think, was a challenge for us. And then, once again, like I said, not all of the equipment showed up as expected. Sometimes with slightly different dimensions, sometimes, like I said, with the extra control panels. And because it was so complex, there was quite a lot of valves and accessories which we needed to accommodate straight run requirements, orientation, clearances. So there was a lot of time spent in this one room just trying to make sure that we've captured all of these components. So talking a little bit about our support and platform design, like I had said previously, with steam systems, I guess we had done stress analysis job, and there's quite a lot of specifics on anchoring points. So just a few images here. Our racks, you can see we have some specific steam anchors there. As well, we ended up supporting some of our pipe from the boiler platforms as well, and that had to be engineered to ensure that the platforms could handle the weight of those pipes. So a lot of coordination with the consultants, our own stress analysis engineer, and a lot of coordination with the general contractor in terms of where these supports could go. I believe some of the walls we couldn't support off of, so there was, just the supports alone, there was a lot of coordination involved in it. One of the notes I wanted to bring up was part of the contractual requirements, going back to this, requesting that we had to, I guess, track all the deviations. Because of the steam design, that's basically impossible. Because there's specific anchor locations that need to be followed, that steam design needed to be modified. So there were so many modifications. If we had needed to track every single change, that wouldn't have been practical. So lessons learned from this, the contract needs to be flexible, I think, to take into account, I guess, potential changes that could happen during construction. And then also the understanding of what BIM means and how we can work as a team, I think, to facilitate this and reap the true benefits that BIM can provide.